In this video we're going to explore Bloom's taxonomy. Bloom's taxonomy, the original, was created in the 1950s by Benjamin Bloom. And what we have here is a basic understanding up through more high-level order thinking. And we go from knowledge, understanding, application, analysis, synthesis, and evaluation. However, in the early 2000s, Bloom's taxonomy has been revised and focused more on action words to help us understand it better. So at our base, we're remembering, then we're understanding, applying, analyzing, evaluating, and creating. When we remember, we're just recalling information. When we understand, we're actually trying to explain ideas, basic explanations. When we apply, we're using that information in a slightly different way. When we analyze, that's when we actually have to distinguish between parts. Evaluating requires us to justify and make a stand, and creating actually causes us to produce something new or take a new stance. Now with Bloom's revised taxonomy, we have some action verbs to help us understand it better. And again, here are the levels, and we really want to try to work on trying to integrate our analyzing, evaluating, and creating types of things, because that is our higher order thinking questions we can ask our students. Again, with remembering, some keywords you'll recognize: memorizing, retrieving, recognizing. When we're understanding, we're just summarizing, paraphrasing, or identifying. When we apply, a keyword in math would be solving. When we analyze, we are comparing or differentiating, examining those relationships. When we evaluate, we have to justify a decision. We have to check and hypothesize, experiment. And when we create, we're actually constructing, planning, producing, inventing. So let's look at a couple examples. So say I'm given the basic problem: multiply 2 and 7/10 by 1 and 75/100. That's just an applying problem because all I'm doing is solving the problem. Now if I'm asked what's the property related to this equation, 3x plus 2 equals 2 plus 3x, I'm just recalling that that is the commutative property of addition, that is remembering. Now here's another problem. So I'm given the work by Tommy, and I want to know, is it correct? If so, explain why. If not, explain his mistake and how to correct it. Now there's a lot more complexity to this because I have to first solve it myself, I have to compare my answer to his, and then I have to determine, is it right? And if it is not right, why that is the case. Because of that, of all those decisions I have to make, it becomes an evaluation problem.